Hello everybody. In this lesson we will be studying about similar figures, about similar triangles, knowing what the definition of similar figures are, how to identify whether two figures are similar or not. So welcome to the lesson. Can you guess how heights of mountains, say Mount Everest, or distances of some long distant objects, say moon, have been found out? Do you think these have been measured directly with the help of a measuring tape? In fact, all these heights and distances have been found out using the idea of indirect measurements, which is based on the principle of similarity of figures. So we will study how to identify similar figures and what is the principle behind the similarity of figures. So let's look at the definition of what are similar figures. Recall that in our lower grades we have studied that two figures are said to be congruent if they have the same shape and the same size. But what about similar figures? Now, similar figures are figures that have the same shape but not necessarily the same size. Look at these circles. They have the same shape but the sizes of the circles are different. So they are similar. Let's look at the triangles. Same shape but different sizes. So they are similar figures. What about this? Same shape but different sizes. So similar figures are figures that have the same shape but not necessarily the same size. So we know the difference between congruent figures and similar figures. In congruent figures, the shape and size are the same. In similar figures, the shape is the same but size may not necessarily be the same. So that is the fundamental difference between congruent figures and similar figures. So when we look at all these figures that are similar, we can say that all congruent figures are similar, but the similar figures need not be congruent. So great conclusions we can come up to from this definition. What about these quadrilaterals? Are they similar? They have the same shape, no doubt. They appear to be similar, but they may not necessarily be. So there must be a definition to find out whether the two figures are similar or not. So the definition is two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So the corresponding angles have to be equal and the ratio of the corresponding sides have to be the same or in proportion. So let us see how we figure out using this definition whether two figures are similar or not. Let's figure out whether these quadrilaterals are similar or not. Now for the figures to be similar, the corresponding angles have to be the same. So what is the corresponding angle of 105, angle A? Angle P, which is 105. So corresponding angle of 100, 100. Corresponding angle of C is R, both are 70. Corresponding angle of D is S, both are 85. So we have figured out that the corresponding angles are same. First point done, first criteria. Now let's figure out whether the ratio of the corresponding sides are in proportion or not. How do we do that? What is the corresponding side of DA? It is SF. How much is DA? It is 2.1. Corresponding side SF, 4.2. How much is that? It's 0.5. What is the corresponding side of AB? It is PQ. So AB is 1.5. Corresponding side PQ is 3.0. And how much is that? 0.5. What is the corresponding side of BC? It is QR. So, BC is 2.5, corresponding side QR is 5.0. How much is that? 0.5 again. What is the corresponding side of CD? It is RS. So, CD is 2.4 divided by corresponding side RS, which is 4.8. It is also 0.5. So, do you observe over here that the ratio of the corresponding sides is in proportion? It's the same. Therefore, both the criterias are satisfied. Corresponding angles are equal and the ratio of the corresponding sides are in proportion. Therefore, these two figures are similar. So, we got the criteria how to identify whether figures are similar or not. The ratio of these corresponding sides, which is the same throughout, this is called scale factor. Remember this. So, what is scale factor? It is the ratio of the corresponding sides of similar figures, which is going to be the same throughout. So, that is called the scale factor. What about these two quadrilaterals? Are they similar? Let's look at the condition 1 for the angles. All the corresponding angles are similar. They are all 90 degrees. What about the sides? What is the corresponding angle of AD? It is PS. And how much is that going to be? 3/3, which is going to be 1. So, the corresponding side of AD, which is 3, and the corresponding side of PS is also 3. So, we get 1. What is the corresponding side of AB, which is 3? And what is the corresponding side of AB? That is PQ. How much is that? 3.5. Do you get 1? We do not get 1. So, the ratio of the corresponding sides is not the same. So, the second criteria is not satisfied. Therefore, these two figures are not similar. They are not similar. So, do you understand now? Both the conditions have to be satisfied. What about these two quadrilaterals? Are they similar? Let's look at it. Let's look at the scale factor. What is the scale factor? The ratio of the corresponding sides. So, what is the corresponding side of AB? It is PQ. So, if you just observe the figure, all the sides ABCD, it is 2.1, and in the other quadrilateral, all the sides are 4.2. So, definitely the ratio of the corresponding sides is going to be the same. The scale factor is going to be the same. Okay, second criteria is satisfied. But what about the angles? Will the corresponding angles, are they same? Look at angle A and angle P. They are not same. So, the first criteria is not satisfied. All the angles have to be equal. The corresponding angles have to be equal, which they are not. So, the first criteria is not satisfied. The second criteria is satisfied. So, these two triangles, these two quadrilaterals are not similar. So, we can conclude either of the above two conditions, 1 and 2, of similarity of two polygons is not sufficient for them to be similar. Both the conditions have to be satisfied in order for the polygons to be similar. So, great going. We have completed the lesson on identifying similar figures. So, in the coming videos, we will learn how to establish a relationship between similar figures. What are the theorems involved in identifying the relationship of similar figures and proving the similarity ratios. So keep watching, keep learning, and keep practicing. Thank you.